Hey guys, welcome back to my channel. In today's class, we are going to study mass fragmentation, its rules. It's very important topic, and it's very easy topic also, because you have already studied homolytic cleavage, heterolytic cleavage, Aldol reactions, rearrangement reactions in your B.Pharm. You have studied many reactions, right? It is very similar to them, and I'm not going to explain it because it makes confuser. It can make confusion between you when you read and when I explain, so that you read and you just understand the concept. It's very easy. If you have not understand any topic, you just comment it for next video, and for the next day only I'll just reply and you clarify your doubt. Okay, see, first there are divided into two types: simple and rearrangement reactions. Okay, homolytic cleavage, you know, right? Equal sharing of the bonds. Sorry, I have made a mistake here. Equal sharing of the bond. If there are electronegative atoms, there is no like higher electronegative atom and lower electronegative atom. These are both equal, so that equal sharing of bonds, equal sharing of the uh, electrons in a bond. Okay. Next, heterolytic cleavage. In heterolytic cleavage, the electronegative atoms takes the both electrons and it leaves the positive charge with the lesser electronegative atom. We'll see the examples. See here, you see here it's an more electron withdrawing atom, so it takes the electrons from the uh, alkyl group also, and the plus ion is formed. Okay, this is the examples of the heterolytic cleavage. Okay, just read and just solve the reactions you can write it on. Okay, next we have the Aldol reaction, which is also like quite similar. If you read, you'll just understand it. I no need to explain, just read it once and you will just understand it. Okay, next the rearrangement. Okay, this is the rearrangement occurs. If you read you'll understand it. It's very easy. Next, this one they have asked once in your exams. Okay, rearrangement ions are fragments. They are formed due to the resulting intermolecular atomic rearrangement due to fragmentation. There is MC Latifer rearrangement. Here rearrangement takes place. Okay, and last, C, elimination. Just read it. These are the reactions. I can't explain it. You should need to understand. Next, the rules. Guys, we will start the rules of the fragmentation. See, the height of the M plus, the molecular M represent molecular and P and plus represent positive. Molecule peak decreases. The height of the peak decreases with increase in the branching. See, the number of branching increases. If the branching increases, then the peak decreases. That's the first rule. Second rule, the height of the M plus peak decreases with increase in the molecular weight. The peak decreases with increase in the molecular weight. See, C16 carbon has a higher molecular weight, the peak has lower. C4 has and C5 has the lower molecular weight, but it has highest peak. Okay, C3 is leave it. I mean excluding it. Okay, next, the cleavage is formed at alkyl substituted carbon leads to formation of carbocation. That's the third rule. The third rule tells that it gives the stability. Okay, carbon stability is order. The cleavage is formed at alkyl substitution carbon leading to formation of carbocation. Here the cleavage is formed to form an carbocation, and this is the order of stability order of the carbon. Okay, after the fragmentation, this is we get this many fragments, and this is the order it's telling. Okay, the fourth one, double bond cyclic structures and aromatic rings stabilize positive charge and increase the probability of its appearance. Okay, here double bond cyclic rings and aromatic rings will stabilize the positive nature of the sample. Okay, this is the fourth rule. Next, there is the fifth rule. Double bond favors alkylic cleavage to give the resonance stabilized cation. See, okay, here what happens if a double bond occurs, right? Uh, it forms an favorable alkylic cleavage to give an resonance stabilized cation. This is the resonance stabilized cation. Okay, the sixth rule tells that a saturated ring tends to lose alkyl side chains at alpha bond. Okay, if an saturated compound is present, it loses the alkyl side at alpha bond. Okay, unsaturated rings can undergo keto diels order reaction. We have already discussed, right? Rearrangement, how it takes place. Based upon the same reaction, here also it goes unsaturated rings. Okay, the third rule, carbon carbon bonds next to an heteroatom are frequently cleavaged, leaving the charge on the heteroatom. See, if the carbon bond is present with an next heteroatom, then there is an cleavage occurs, leaving a charge on the heteroatom. Here the cleavage occurs here and leaving the charge on the heteroatom. Here Y is oxygen, nitrogen or sulfur. Okay. The ninth rule tells that the cleavage is often associated with elimination of small stable neutral molecules such as CO, CH2, NH3, C2S, CNS, ketone and alcohol. This is example of MC Lastifer rearrangement. Here cleavage happens due to presence of these molecules. Okay, this is the ninth rule. Next, we will understand metastable ions. What are metastable ions? Okay, ions resulting from decomposition between the source region and magnetic analyzer are called as metastable ion peaks. See here, the decomposition or the breakdown between the ion source and the magnetic analyzer is called metastable peaks or metastable ions. Okay, an ion of mass 1 is accelerated after initial ionization, but a different ion M2 daughter cells passes the magnetic analyzer. The resultant peak is neither M1 or M2 but appears at M, metastable. Okay, see here, if the M1 and M2 are the different type of ions, when passes through the detector, the resulting data is neither M1 or M2 but it's an metastable. Okay, which is not stable and trying to stabilize itself. Okay, for metastable atoms, to find out the metastable, M2 by M1 whole power 2. Okay, this is the equation to determine the metastable ion. These metastable ions are formed during 10 to the power of minus 5 seconds. Means it's like 1 for 1 second divided by 10,000. Okay, that much small, less time is required to form and stabilize. Time spent between the electrostatic and magnetic analyzer, 10 to the power of minus 5, mean 1 second divided by 5 zeros, ones, tens, hundreds, thousands, 10,000, 10,000. Okay, that's much a small time is required to form. Okay, a quite broad but provides direct information about the ion reaction. It's an quite broad, but it also provides the information of the reaction. This is called metastable ion. Okay, or metastable peak. Next, isotopic peak. Okay, the isotope are obtained when a molecule contains heavier isotope of certain atoms than the common isotopes. See, if isotopic peaks are formed when the molecular containing heavier isotope of certain atoms than the common isotope. If we use the heavier isotopes than the common, then isotopic peaks are formed. See, commonly seen isotopic peaks are M plus 1 or M plus 2. Intensity of isotope peaks is much less than that of M plus peaks, except where ClBr is present in a molecule. Here, if the charge ratio is 1, then this is normal, but it present in plus 1 or plus 2, then the isotopic peaks are obtained. Okay, a peak that M plus 1, a peak that is 1 mass unit higher than M plus. Okay, M2 plus, a peak that is 2 or mass unit higher than the M plus. Here the mass is increasing than the charge. Okay, these are called as isotropic peaks. Intensity of isotropic peaks depends on the relative abundance of the isotope in a nature. For a compound containing one carbon out of every molecule, see here, C12 carbon, it is 98.92% in a molecule, but C13 isotope is 1.028. If it is present, it causes isotropic peaks. I think so I understood. See, M plus 1, these are the atoms. For M plus 2, these are the atoms. If these two are present, isotopic peaks are formed. These are the applications of the mass spectroscopy. You have, see, you can just see it, right? Just write down the mass applications of mass spectroscopy, and for this is the video. We'll end the everything mass spectroscopy. Next video we'll start the chromatography. Okay guys, see you in the next video. We'll start with the chromatography, and hope you are understanding. And I am also a student. It's like a bit confusing, right? If you read one or twice, you will just get it. Thank you guys for watching. Please subscribe, like, and comment. It will make my day. Thank you. See you in the next video.